Do you trust AI to make business critical decisions, right? Do you trust AI to do tasks for you on real enterprise systems and real enterprise data? Except for 3 people, no. The reason is AI cannot be 100% accurate, 100% explainable, 100% steerable, 100% repeatable, and 100% secure. By that, what I mean is, can AI be, can the answer that my AI gives me, is it exactly what it said it will do, and is actually what it ends up doing? Is it accurate in that? Can it explain to me why it did what it did? Can I guide it towards the right answer? Even if it does not give me the right answer, if at least I understand its approach, can I guide it to the right answer? And once I've guided to the right answer, next time if I ask the same question, can you repeatably give me the same answer? And on top of all of that, can you ensure that your AI can only access data that you as the user have access to? These are the 5 key hard problems to solve with AI today. But imagine if your AI was like that, right? But today's AI isn't, right? Like all of these big enterprises building these AI systems out there, they don't work. Like take, for example, Amazon's Rufus, right? This is their AI on Amazon.com. I ask it a question like, how much have I spent on coffee in 2024? And I clearly have bought coffee 9 times in 2024. It says these are some of the coffees you might like. How is this relevant? Where are the $2 trillion going? I don't know. Case 2. Gemini on Gmail. You can argue that they just haven't connected that data to Rufus. So at least politely say that you don't know, you don't have access to that data, right? But Gemini is connected to Gmail, right? And I ask it a question like, how much have I spent on Uber in 2024? It says this is how much you've spent on Uber Eats. But I was asking about Uber trips. So how much on Uber trips? It says $73. These are all my Uber receipts just from the month of December, right? I've spent thousands of dollars on Uber, unfortunately. But it's clearly a lot more than $73, right? I ask it, how did you get this answer? It says I saw 3 emails. How did you just see 3 emails? Completely inaccurate, right? But then you might argue that this is a consumer AI, right? Doesn't matter. Consumers don't matter. They don't pay the big bucks. Okay, enterprise AI. Let's look at Einstein on Salesforce. With the entire agent force revamped, enterprise AI needs to be accurate, needs to work on real data. I asked my Einstein, we are an enterprise SaaS company, so we asked our Salesforce Einstein, can you calculate the average sales cycle of this sales cycle for a company? It says that I can't help you, but if you follow these steps, you might be able to generate a report yourself. Okay, no worries. I refresh the contest, ask it again, what's the average length of our sales cycle? This time it says it's 71.6 days. Suddenly it has access to my data. So I asked it, how did you get this number? And it says that I took the average of the stage 1 to stage 4 age length field, and that's how I got this number. I said, okay, but first of all, we have 7 stages, not 4. So can you look at all the 7 stages? So it says that, okay, hold on a moment. I look at all the 7 stages, never came back. So I refreshed it again, asked the same question again. What's the average length of our sales cycle? This time it says 2.21 days. You just said 73 days. How are you telling me it's 2.21 days now, right? So can you explain how you got this number? Gives you the same explanation, stage 1 to stage 4 age length field. So AI is completely inaccurate, completely non-repeatable. And this is happening with enterprise AI, with billions being poured into it, right? The problem is with the approaches that we're taking, right? We've heard about RAG, tool calling, multi-agents, text to SQL, all of these different approaches, right? But all of these are in-context approaches. We expect the LLM to call the right tool, do the right semantic search, orchestrate the right sub-agent, generate the right SQL query, pull that data, take it back, consume the data back, and give me an answer, right? But the problem is LLMs are really bad at processing massive amounts of data. And you can see, with all of these different approaches, I encourage you to take a screenshot. So you can argue that I can solve a specific use case with semantic search, I can solve a certain use case with tool calling, something with multi-agents. But the problem is all of them lack one or all of these capabilities, right? How do I access data from any kind of data source? Enterprises have their data in SQL databases, NoSQL databases. They have their own custom APIs, microservices, SaaS applications like Salesforce, Zendesk, and I have data spread across multiple data sources. Second, my AI cannot really do computer logic, right? How do I handle 1 billion rows of transactional data? How do I do correlation analysis between one column in BigQuery and one column in Postgres? How do I make sure I'm not limited by the context window? Read my last 10,000 support tickets and tell me what has been the general sentiment about my product. How do I fit 10,000 support tickets into my context window? How do I ensure authorization for every single type of data source, right? I should only be able to access data that I, as the user, am allowed to, even before the AI comes into the picture. How does the AI plan a multi-step query where I need to fetch data from this place, then based on the, analyze the data somehow, based on the analysis, I might need to fetch more data, ask the user for some more information. These kind of multi-step query plans, how does my AI generate? And finally, if my AI messes up somewhere, in the sense, wrote the wrong SQL, right? Or made wrong assumptions, how does my AI heal itself, understand what the issue is, and then course correct, self-correct? That's the problem with all of these in-context retrieval methods. And one thing we should note here is that LLMs are really good at planning. You ask them a general strategy based on the data landscape, they'll give you a great strategy. And they're really good at planning, so let's use them for planning. But what LLMs are not good at is processing large amount of data in context. So how can we separate these two apart, right? Just use the LLM for the planning, do not use the LLM for the actual execution. Once you do that, you are able to build an AI system that can answer a question like this. Like, imagine an AI system trying to answer a question like this, right? Find tickets raised over the last 7 days by enterprise customer, like a typical customer support assistant, regarding service timeouts where our SLA was not met, and identify whether they were satisfactorily resolved, and issue $100 of credits to the users it wasn't resolved satisfactorily. So what's happening here? Tickets is coming from Zendesk. I have to put a structured filter on Zendesk data. I have to join that data with my enterprise, like my customers' plans and customer data, which is, let's say, in BigQuery. Regarding service timeouts, I need to look inside each ticket and identify whether this ticket is about service timeouts or not. I have not labeled or tagged my tickets. Where our SLA was not met. So I need to understand that, okay, when was the ticket created? When was the ticket closed? What was the SLA that was promised? And was it more or less than this SLA? Identify whether they were satisfactorily resolved. So I need to look at the entire back and forth between the customer support agent and the customer and see whether there was satisfactory resolution or not. And if it was not, then issue $100 of credits to each of these customers. So I need to call an API, let's say the Stripe API, and issue these $100 of credits, right? So I tried building this out with Claude O1 and O3 Mini with tool calling. So I gave it, I moved all my data into Postgres. I gave it a Postgres tool, for example, an MCP server and stuff like that. So I gave it a text-to-SQL tool. I gave it a Python tool as well in case it needs to do this kind of SLA calculation and stuff like that. And I asked it queries like this. This is an example of a medium complexity query. I have much more complicated real-world queries and very simple real-world queries as well. And this was the performance. This was the average accuracy across my questions. For complex tasks, extremely poor, less than 25%. Rust with large data, like many support tickets, many customers, Claude completely fails. The other two are also not that good. So now, if we take this principle of separating planning and execution, right? And what if you could generate a 100% accurate task-specific agent on the fly for any user query? If I ask you, like for a specific question, very simple, easy user query, can you create a task-specific agent which can answer that 100% accurately? You'll say yes. I won't even use an LLM. I'll just write code for it, right? Perfect. Another query, you can do it. Another query, you can do it. But user can ask whatever they want, right? Give them a free-form text box. They'll ask whatever they want. How do you build agents on the fly which are 100% accurate for specific tasks? So if you're able to achieve that and then execute those agents deterministically, you can get 100% accuracy on any user query, just with this principle. And I tried that. That's what we call PromptQL. PromptQL beats all of these models, blows them out of the water with real-world questions, real-world enterprise questions on real-world enterprise data, and this is our enterprise data. I can sense the skepticism here, and which is fair. So how? Why? Right? So PromptQL is a data agent that gets you to 100% AI accuracy. How? We separate query planning from execution, and we implement task-specific agents on the fly. But my data, let's say, for example, is in Postgres and Snowflake, my structured data. My unstructured data, I have some in Pinecone, some in VV8. I have my SaaS applications that I need to connect, and then I have custom APIs, custom logic that I want to connect. Do I make my LLM do semantic search, do tool calling, do text-to-SQL? Like, how do I build this out, right? What if you can abstract everything out into a single data access layer and then just give that data access layer to the LLM so that there's only one way to access data, does not matter what kind of underlying data source it is. And then let your AI plan how to access that data and implement a programmatic agent on the fly and execute that programmatic agent in a separate sandbox outside of the LLM's context. What happens is you suddenly achieve all of these lacking capabilities in your AI systems. So it's better to see this in action, right? I have 5 minutes remaining. So let's see this in action and see how an AI assistant, which is built on these 5 principles, can actually get you to 100% accuracy. A unified semantic schema across any kind of data source, doesn't matter, and the ability to access any data inside that schema. The ability to plan a multi-step query, which might have data retrieval, data compute, data processing, composition, doesn't matter, and the ability to execute on that query and self-fix on failure. Structured memory, which is beyond context windows, right? I retrieve, let's say, 10,000 rows of data, and then I want to ask a follow-up question on a subset of that data. Do I expect my LM to remember all of that data? I don't, right? So how can we go beyond these context windows? And then, of course, fine-grained and role-based access control, fundamentally required for any enterprise application. So let's look at a demo. So a similar assistant, which is connected to, I can't show my enterprise data, so this is like a mock version of the same data. It's connected to the user data, product usage data. We are an enterprise SaaS company, right? So we have a bunch of organizations that we serve. Each organization has a bunch of users. Each user can have projects. We bill per project. And they also can raise customer support tickets on Zendesk and stuff like that. So I've asked a question like, how many unique organizations do we serve? My organization ID data is messed up. So don't use that to find the unique orgs, right? Maybe use user details, like figure it out how to find a unique organization that I serve. Then for each unique organization, tell me how many users they have, how many projects across all their users, and then total billing across all projects of that org. Difficult question, right? Let's see how PromptQL approaches it. PromptQL will first look at this unified data access layer, look at the schema in that layer, and come up with a query plan of how I should approach answering this question. That I'll get all the users and extract their email domains, smart. Then group users by email domains. Then for each organization, you see how it's writing these loops on the fly. Count the number of users, get all projects, then store the results in an artifact for you to see. It implemented that agent and executed that agent. LLM's job was over once it did the query planning and the agent implementation. After that, the actual data retrieval, data compute, everything else was happening deterministically. And I get my response, right? I have 19 unique organizations that I serve, number of users, number of projects, total billing. Perfect. This data, the LLM has never even seen. Look at the LLM's response. It says that you have 19 organizations. This is their data. I don't even know what that data is. This is the artifact that sub-agent gave me. And so when I say agent, it's not an AI agent per se. It's like a more script, you can say. OK. So, but what if I wanted more information? There's something that you did not include. Can I edit your brain? Can I steer you? All I have to do is edit this query plan. I click on this, and I'll be like, after this step, can you also tell me how many total requests across all projects for each org? Right? So they have multiple projects. Each project, so we are an API product, right? So you get a bunch of API requests. So can you tell me how many total API requests across all projects? So it says, OK, I understand what you're asking me, but I'll also add these specific metrics when answering your question. Again, it's implementing that agent. It'll execute that agent, and then give me the answer. So let's see. OK. Exactly same answer, repeatable, 19 organizations, but with extra response on the total requests. OK. Just so that I can be fast at typing, let's do this. How many support tickets do the first 3 of these orgs have across all their users? OK. Follow-up question. Now, when I say these, right, these, I expect my LM to remember what I mean by these, right? But my LM has never even seen this data. That's where the structured memory comes in. If you look at what PromptQL is doing here, get the top 3 organizations from a previous artifact. So the structured memory is what it is using to answer my follow-up question. So I know my data, my answer can never be hallucinated because it's coming from a structured memory. LLM is not trying to remember anything here. Second is I'm doing a join across data sources, right? I'm doing a join from my Postgres data, let's say about my users, and my Zendesk data. And I get this, they have 68, 33, 24 support tickets. OK, awesome. So let's say if I ask a question like, fetch the details of all the, this is a new question. So 24 support tickets by horn.biz, right? The third organization. Horn.biz. Let's do this. OK. Now I'm asking, fetch all the details of the 24 support tickets by horn.biz, including the comments on those tickets, then summarize each ticket thread and show me just the ticket ID, subject ID, and summaries. Then combine all other relevant metrics about this org, including the summaries of these tickets. Then extract the org's risk of churn, create 5 categories of risk, And what is going well, what's not going well, what can we do better, right? Such a complicated question. Structured data retrieval, unstructured data retrieval, semantic analysis, a bunch of these things, right? Again, so it's a complicated agent. It says that I'll get all the support tickets. For each ticket, I'll get all the comments, combine the ticket, use AI to summarize the thread. So what it's doing basically is delegating that task to another downstream LLM. Like, I can't pull all the ticket details into my own context, so I'll break it down ticket by ticket, and I'll call different LLMs to basically do this task for me. And that's exactly what it does. It executes that, comes back with a response saying these are the support summaries of each of those tickets. Perfect. There are 24 tickets, so I can just expand this. 24 tickets, perfect. And then I also get a nice churn risk summary, what's going well, what's not going well, recommendations. Okay, one last thing is making your AI do things for you, right? Find this org's highest billed user, then find that user's highest billed project, and issue 2% of that project's billing as refund, okay? It's connected to Stripe, it can issue refund. So find these details about that specific user, that specific project, and issue refund. Okay. Exactly following instructions, implementing an agent, will execute that agent, call the Stripe API, and issue the refund. But I do not want, okay. Oh, this is the great example of self-fix, right? I noticed that the first query worked, but didn't print the refund details. Let me execute the refund part explicitly, right? You see, there was something went wrong with the refund, understood what the issue was, self-fixed. Then this is the human in the loop, right? You don't want your AI to just do any action on your behalf without your own approval, right? So it's my data access layer, which is deterministic, is saying that your AI is trying to call this function. This is the parameter that it's passing. Are you okay with that? And if I click on approve, it'll let it pass through. It'll call the Stripe API if it chooses to respond, and the refund will be issued. So now you see how you can actually achieve 100% accuracy on real enterprise data, no matter the scale, no matter the type of data. And it's no longer a pipe dream and no longer dependent on the quality of the LLM. All of this has been running on Claude 3.5 Sonnet. No reasoning models, nothing. And that's why PromptQL's graph, that was with 3.5 Sonnet, not even with any reasoning model. Okay, refund was issued. So that's PromptQL. Try out PromptQL. Build something unique, something great on real data. Doesn't matter structured, unstructured. Basically, it's one agent to rule them all. RAG, tool calling, multi-agent, everything is covered. Thank you.
Great. All right. So we have a few questions.
Hey, first of all, this is amazing and mind-blowing, trust me. Because we have been trying to do this, achieve this, and it's like almost impossible. So the question I have is, you have mentioned, like, two questions. So first of all, you have mentioned in your slides that it's almost 100% accurate. So can you tell us where it was not accurate in your testing, this approach?
Fair question. So see, the thing is, it's steerable. So you can always push it to 100% accuracy. So the reason why I don't want to claim it's always 100% accurate is because it's not a one-shot system, right? I ask a question, you give me a 100% accurate answer, maybe not, because you interpreted the schema incorrectly, right? That could be possible. But because it shows you the query plan, it shows its thinking, you can edit it, you can tell it, no, this is what you should have done instead. And you can guide it towards 100% accuracy. It's already close to 100% without you needing to intervene, but it can go to 100% with your intervention as a user.
But like that is what we don't want to do, right? Because almost all these tools have the option to edit the step in between, and we don't want to use and do that with PromptQL. So like, have you guys seen those inaccuracies in your testing? And it's possible that you, because
yes.
Okay.
Oh, for sure we have, yeah.
Okay,
so which is why I say I put the tiny tilde before the 100%, right? Yeah. But it's very close to 100%, but I do not want to make a false claim that in a non-deterministic system, I'm able to achieve 100% accuracy. That's not possible, but I'm able to push it towards 100% and make it actually useful for enterprises. And that shows with all of our enterprise customers, which are most of our Fortune 100 companies.
Perfect.
And yeah.
Just one more question. So you have mentioned that you guys are able to achieve this accuracy because you guys determine the steps on the fly, right? But isn't that what text to SQL is? Because we just give it some text and it converts that to some query, which is being generated on the fly. So how is your process different?
100%. No, that's similar to what we're doing, but let's say you also have MongoDB, right? Or you have SQL and MongoDB, right? So how do you, and then you have to do some kind of join, cross-domain join between a Mongo collection and a SQL table, right? So now, do you first run your SQL, pull out the data, give it to the LLM, then do a Mongo query, like generate a Mongo JSON, and then do that? You won't do that, right? But that's where the non-determinism comes in. So what we do is abstracted your data access under a single data access layer. And that layer is doing deterministic data retrieval. There's a one way to talk to that layer. That's what PromptQL uses. Second thing is, the query that PromptQL generates to access data from this data access layer, that is called not by the LLM, but inside a programmatic runtime. So if I just show one of these to you very quickly, like for example, this one, it's a dialect of SQL, but all of that is happening inside Python. And it's complete transparency. This is exactly what the agent that it implemented. Even like an API call looks like a SQL stored procedure because that's our, the virtual SQL layer that we have that talks to the data access layer. That's like a dialect of SQL. So even like functions and tool calls, all of them will look like stored procedures in SQL. But all of this happening is in a programmatic runtime. The LLM is never seeing the response of the SQL statement. Mm-hmm.
So thank you for the amazing presentation. Question is, so how much of this do you do on the fly in terms of the coding? So do you have specific functions that are already encoded that can do specific things? For example, if the user asks something that you have not pre-coded, maybe you're using function calling to call the specific functions, you're writing everything on the fly. What are the limitations?
Great question. So two things here. One, if you boil down every possible user interaction, right? Like you can boil it down to like zeros and ones, right? So for us, we abstracted it to three key concepts. One is data retrieval. Second is computational processing. Third is semantic processing. With these three things solved, you can, combination of these three, like your logical gates, you can achieve any task. So data retrieval is happening through this virtual SQL layer, which is the Hasura DDN. Second is data processing. So PromptQL, by design, writes Python agents, not AI agents, right? So it writes Python agents, so that handles computational tasks. Third is semantic tasks, which you can't achieve in Python. So you have PromptQL has the ability to call to do a semantic task. Like, can you tell me the sentiment inside this support ticket? So that's a semantic task, right? So it's just like a simple LLM call function, which it can use. Now, if you want to add your business-specific logic and functions, right? For example, you have traditional machine learning model, which tells me what is the next best product recommended to the customer. I want to add that here. So I can just add that as a command to as an API or a logic connector to my universal data access layer. So now you can add custom things which are beyond the scope of these three basic concepts. If you have your own.
Gotcha. So if I were to come and use as a customer, so basically I would define these business logics, and you in the back end are going to write code before the execution, before the user starts asking questions.
No.
Like how does it work? Like walk me through from me going to your website to actually using it in a very useful production. Right?
Okay. Step one, you basically install the CLI. You connect your data sources to Hasura. AI hasn't come in the picture. You connect your data sources to Hasura. Hasura introspects your data sources, pulls out a schema, builds a supergraph. Supergraph is this. Like this is an example of a supergraph for our internal sales agent. So it's connected to Salesforce. All the Salesforce data, Salesforce views and Salesforce tables. It's connected to our call transcripts in Clary. We have exposed a bunch of semantic search functions. It's also connected to Perplexity for any kind of internet search that's required. So it builds this supergraph. And that's the universal schema for the LLM to look at. And then simply, your user query, this schema, we ask the LLM, can you write code to access data inside the schema and process that data, however. And these are the operations that are possible. You can write Python, you can call an LLM, and you can write our virtual SQL. That's it, three things. And that's how we execute that.
Cool. We have time for one more question, but I do have a question for the crowd. Is anyone with GMI Cloud here? GMI Cloud? Oh, cool. Okay. Just making sure. All right. Where was the...
Hi. Great presentation there. Question on role-based access control. I saw there was some control where AI simply asked whether you approve the call or not.
Correct.
Now, based on login, what if user doesn't have access?
Correct.
Do you limit it to people because data system is huge.
Yeah.
Some people might have access to one set of data,
Correct.
Might not to another one.
Yeah.
Have you thought about this? What's your thought?
Yeah. So
if you can go.
So we have either role-based access control, or you can have like fine-grained access control, like JOT-based or OAuth-based. So basically, like our customers are enterprise customers, right? And they have multiple scope of access control rules. So let me just show you one example very quickly. Let's go to customers. Like for example, the customer's data, right? Now, I, as a customer, should only be able to look at my own data, right? I shouldn't be able to access all the data. So I have this access control rule defined that only show me the data where, in this table, only show me the fields where the customer ID is equal to my session variable, right? Else you shouldn't be able to, I should not be able to see the scene. So me as a developer, I can set up these very fine-grained rules if I want, either on a row level, on a column level, on a table level, on a subgraph level, whatever I want. So you can do that. You can go schema by schema as well, yeah.
All right, thank you.
Thank you so much.
Give them a round of applause.